Okay, in last lecture we discussed about the bitwise operator, and in that we discussed about the binary operators and XOR and OR. Now today we'll discuss about the left shift, right shift, and negation operator. Okay. So first of all, we'll discuss about the negation operator. In that negation operator, we need to perform the two's complement operator. So first of all, I will show you what will be get answer, and after that, according to that answer, we need to perform. In that, I will describe two different aspects. So, like in other languages like C language, C++, and Java, how the negation operator will work, and how Python language will work. Okay, let's discuss about the negation operator, and afterwards we'll discuss about the left shift, right shift, okay, and the key points of negation operator. Because in the interviewer must ask the question regarding the negation operator, like how will store the number inside Python? Can I able to store the negative number? Okay, so like that stuff they will ask, and how we generate the even number into the negation number. So before that, let's start with ideally tool. In that I will open the ideally tool, and just I'm trying to save one variable inside that one value inside that variable. So assume that the variable name is x, and that contains the value 10. Okay. And now when we perform the negation operator of that value, see this sign indicates the negation operator till side. And when I use this negation operator with a given variable, we get a different kind of value. Okay. So like we get the minus 11. So we need to justify why we get the minus 11. Okay. So before starting the negation operator, I want to say a few things regarding that negation operator, and such a type of things will ask in the interview also. Then that means, so here I will open the notepad and let's discuss about this point, and after that we'll clear the negation. So first of all, we'll check the another aspect of negation operator, like in other language, like in C, C++, or in Java language. Okay, how the negation operator. In that section, so we all know that these are the statistically typed language. That means if you want to declare any variable, we require to use a data type. And when we got the data type, the ranges concepts are also available. For example, for 1 byte is there. So for that we have, there are two types of ranges, signed ranges and unsigned ranges. So when we talk about the signed ranges, so we have 128 to 127. Okay, this range is called as a signed range for 1 byte. When we talk about the unsigned range, then we get 0 to 250. That when we talk about the 2 byte range in other languages. Okay, so carefully look at that. So we have minus 32,768 to 32,760. This one is the signed range, and when we talk about the unsigned range, 0 to 65,500. Why we required this range? So in other languages, if you want to calculate the bitwise operator, if you want to calculate the value, then we require these ranges. Okay. So let's talk about, assume that if we have a 10 number, then we will convert that 10 number into binary format. We all know that how we'll convert the binary format. Okay. So the representation is 8 bit. Okay. So we get the value as 1010, and before we need to write 0000 is to perform the negation of. So here we perform the ones complement. Okay. So I'm discussing the older version. Don't worry about the Python. Okay. So in that section we apply the ones complement. Here I'm trying to apply the ones complement. Ones complement. So we get the value 111. So ones complement is nothing but if we have a 0, then we get 1. If we have 1, then we get the 0. Okay. So all zeros will be replaced by 1. So this 1 will be replaced by 0. This 0 will be replaced by 1. This 0 will be replaced by 0. 1 will be replaced by 0, and 0 will be replaced by. So in that section, if you want to calculate the range, the upper bit is most important. Okay, so make a range, make a note of that. In 8 byte, 1 byte, okay, 1 byte, the upper bit is negative. Why? because the when we talk about the 8 bit, we have calculate like this, like 1, 2 is there, 4 is there, 8 is there, 16 is there, 32 is there, 64 is there, and 128. So when we count these numbers, so we get the 8 bits. Okay, 1, 2, 3, 4, 5, 6, 7, and we all know that in one byte the upper bit is always negative. Okay, so when we talk about that and when we apply our logic inside that, then we get the result. Okay, for example, 120 bit is 1, that around 61 is a 1, is a 0, and this one is 1. And when we perform the addition of this, we get the actual value. Okay, so like that stuff we do in C, C++, or Java language. I will do the addition. We all know that the upper bit is a 128 and the 128 bit is a minus. See the color combination. So this one is a 128 and we have minus 128. So that means we need to perform minus 128 plus 64 plus 32 plus 16 and later on 1 is. So let's do the addition. So when we perform the minus 128 into 64, we get a value as a minus 60. When we perform minus 64 plus 32, then we get the minus 32. When we perform minus 32 plus 16, then we get minus 16. When we perform minus 16, then plus 4, we get minus 12. And when we perform minus 12 plus 1, then we get the actual value. We get the actual value. Value is minus 11. Given a value as a 10 and we get the output as minus 10. But this is a not proper way. This is the not proper way to get the numbers. This is the we get the answer, but this is the not proper way to get the answer. Let's took the another example in Python, so we will get the idea regarding that. Okay, so what Python says that if you want to store the number Python in the Python, if you want to store if you want to store number side Python, then number the number must must be most important statement I have made. Number inside the Python, then that number must be a positive. Then another question will arise is, so if you want to store 10, 20, 30, 40, that will be okay because these are the positive numbers. But when we talk about the minus 11, minus 20, minus 900, like that stuff, able to store the inside the Python? The answer is yes. But here I made a statement, if you want to store the number inside the Python, then the number must be a positive. So what happened? This negative number will be also stored inside the Python, but in the form of positive by using 2's complement. So that means here I will make another statement. Negative number also stored with 2's complement. The negative number will be converted into 2's complement. That means we get the positive number and that number will be stored inside the Python. This is the way by using that you can store the number. Now, how we will understand what is the number that will be stored in a what we say that number will be stored in Python. Okay, let's take one example. So here, what should I do? I will use a binary over here. So here I'm using x is equal to 10. Let's take one example of x is equal to. We all know that we have a given number as an integer number. We need to convert it into pi. So we all know that the 10 of binary we get in 4 bits. Okay, but the representation must be in the 32 bits. The representation must be in the form of 8 bits. So like that we need to store. So let's assume that we have 8 bits. So 128 is there. Afterwards, 64 is there. 32 is there. 16 is there. 8 is there. 4 is there. 2 is there. 1. So this one is the formula by which then we can calculate the binary, and we get the values like 0, 0, 0, 0, later on 1, 0, 1. So here we need to apply the ones complement. Here we need to apply the ones complement. Ones complement is nothing but the given number will be changed in the current state. Okay. So here I will write the ones complement rule. So don't be confused in the Python. Okay. So we will get the answer, but don't be confused. This will be the internal operation, and such a type of question will be asked in this section. So this important section is the most important section. So here the interviewer may ask the question regarding that what is a bitwise operator, how we can store the negative number. The Python says that we cannot able to store the negative number. Then again we will store the negative number. Then what is the reason? We can store the negative number in the Python with the help of two's complement. What is the rule of two's complement? Here we did two's complement is nothing but first of all we will do one's complement, and later on we can add the plus one. So that term called as a two's complement. Let's do that. So this one is a negation number of this one is a binary number of 10. Later on we need to convert it as a ones complement. So here 0 is replaced by 1. So in that two's complement, one's complement is nothing but 0 is 1 and 1 is two. We add the ones complement. So 0 replaced by 1, 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 1 replaced by 0, 0 replaced by 1, 1 replaced by 0, 0 replaced by this value we get. This value we get. And this value is nothing but minus 11. So how we can say that when we add all these element, then how we will get the minus 11. Okay, so minus 11 is similar. I will do that operation. Okay, so yes, I will identify that. So I have another example. Just make a note of that. Here I make a statement that this value is called as a minus 11. Okay, so if you want to check by using ideally, you can check. So this is the binary of minus 11, but let's prove it. How we can say that this one is a minus 11. So now we'll calculate the binary of minus 11, and we will check the output of this. We'll check output of this with this. Okay. So, first of all, what should I do? I will calculate the binary. Okay. So these are the 0, 0, 0, and later on we all know that 8 is used. So 8, 0 is not used. 4 is 8, 4, 2 is used, and later on 1 is used. So this one is a binary of what? 11. Positive 11, not negative 11. When we talk about that, so this is a binary of 11. Okay, let's do that. We will calculate the binary of only 11. So can I say that this one is a binary of 11? Yes, because see here I'm using 8 plus 2, 10, 10 plus 1, 11. So only 3 bits are using 8, 2 and 1. So here we 8, 2 and 1. And rest of all bits are. So let's do one thing here. I will do what? I will do ones complement. Do ones complement. all know that one's complement is not nothing but what? In that one's complement is nothing but 0 to 1, 1 to 0. So just 1 minute. Let's do one's complement. Here we get 1, we get 1. Later on we will call 2's complement. We'll call 2's complement. So here I'm trying to call. See, 2's complement is nothing but just we need to add plus 1 to the actual plus 1 to the actual value. So 0 plus 1 we get the 1. So 0 as it is रहेगा, 1 as it is रहेगा, 0 as it is रहेगा. Rest of all bits are 1 as it is. The values will be digits are 3, 4, 1 is this value we get. The 2's complement we get this value. Now we need to check. We need to check this upper bit. Okay, make a note of that. Here I will write one more step. If starting bit is 0, then even bit, I'm talking about the bit. This one is a starting bit of. So starting bit is 0, then given number is if the starting bit is 1, then the given number is negative. This type of question will be asked in the interview. So when we talk about this last option, see the starting bit is 1. That means the given number is a negative. This one is negation of minus 11. This one is a negation of minus 11. When we talk about 10, the starting bit is a 0. Then that means the given number is a positive. So all student must know that when we perform the 2's complement, 2's complement is nothing but first of all we need to complete the 1's complement. That means those values are 0 that replace with 1 and those values are 1 that will be replaced with 0. Okay, so that will be the 1's complement. When we talk about 2's complement, just we need to add one element. Just we need to add one element. Okay, so 0 plus 1 we get the 0. Now just check this value with this one. Does it similar? 1 4 times 1 we get the 4 times 1. Later on we get 0. Later on we get 0. Later on we get 1. Later on we get 1. 0 1 0. What does it mean? So can I say that this value is minus 11? Yes, we can say this value is minus 1. About this value, this is the one's complement of 10. The one's complement of 10. We get this value. So this value and this value are matching. Now we can say that when we press x is equal to 10, we get this value minus 11. We get the minus 11 because negative number are not stored in memory directly. That number will be stored in the form of two. So hope so you will get the idea. So let's do one another example. Is there any need to do another example? Did you all get the concept? How many students are joining? So Upendra, did you get the concept? Yogeshwari, shall I explain one more example?
Sir, can you explain once more? Because
Okay.
I didn't get how it converted in minus 11.
Yeah.
I
Okay.
understood about the 2's complement.
Okay. No, don't worry about that. So let's take one another example. So in that, just will do operations. See, assume that. So here I will use x is equals to 15. Just I will take one smaller example. then you will get the confuse. So first of all, we need to convert that x into the binary. Just I will use first 4 bit as a 0. Why we need to use the first 4 bit? Because see, we need to perform the operation. In Python, whenever we store maximum, the limit of that bit is 32 bit because Python supported 32 bit. So that bit will be represented in the form of 32 bit. But for better understanding, here I am using only 8 bit. Okay. So what will be the binary of 8? The binary of 8 will be look like this. Is it valid? Can I say that it is a valid binary of 8, or is there a need to write the
Yes,
numbers
sir.
upside to the variable? So this is the binary of 8. Now what should I do? Here I will do only ones complement. What should I do? Here only do ones complement. So here I'm trying to use ones complement. That's it. And I will close it. Okay. So जैसे भी मुझे ones complement मिलेगा उसके बाद मैं close कर दूँगा. Now this one is a ones complement. Now, when we perform the ideally, okay, so here I perform x is equals to add, and now I'm trying to use negation operator of x. We get the what value? 9. We get the value 9. Which value we get? Minus 9. So now just I want to try and calculate the nines binary. Okay, we get the when we need to calculate the nines binary. So what will be the binary of 9? So we all know that 0, 0, 1, 0. Is it a valid binary of 9? Is it a valid binary of 9? Yes, it is a valid. Now what should we do? We calculate the ones complement. Okay. Ones complement of what? 9. Okay. Here I made one statement. The negative number also stored in a Python with the help of two's complement. That means we need to apply two's complement for negative value, not for the positive value. So that's why here I'm not applying two's complement for the 8 because the number is already stored inside the memory and we don't worry about that. Okay, but when we talk about the 9, okay, so 9 is we need to calculate the binary of only 9. Okay, so that means we not able to calculate the two's complement, but we require to use minus 9 because when we use x is equals to 8 and when we apply the negation operator we get the minus 9 value. Here we get the minus 9 value. So now we need to check, okay, does it performs very well. Okay, so just I'm using a 9 and I'm trying to use the binary of 9. I'm going to perform the ones more. 1 1 to 0. So what I said that here just the negative numbers are also stored in a Python with the help of two's complement. That means where we need to apply the two's complement concept for positive number or for negative number. Obviously, we need to apply the two's complement for the negative number. So here, what should we do? Here, we apply the two's complement concept. Here, I will write two's what to negative number. So here I will add. So what is a two's complement concept? Two's complement is nothing but just we need to add one value with one's complement. I will calculate the two's complement. First of all, we need to calculate the one's complement and later on we need to add just one value, single value to the that one's complement. So here we get the value. See, 0 plus 1, how many value we get? 1. 0 plus 1 means what? बाकी as it is 1 1 ही रहेगा. Okay, so here I will write 1, but here space is created. Now we get the again 1. Okay, later on we again get the 0 because ऑप्शन ही नहीं है ना नीचे. ये +1 है मतलब यहाँ ओनली ऐड होगा है. रेस्ट ऑफ ऑल बिट्स आर द 0 ना आगे का. सो एज इट इज ही ऐड हो जाएगा. Okay, so better understanding यहाँ 0 0 0 0 ही ऐसे assume करना है. So 1 plus 1, sorry, 0 plus 1 we get the 1, 1 plus 0 we get the 1, 1 plus 0 we get the 1, 0 plus 0 we get the 0, 1 plus 0 we get the 1, 1, 1. This is the 2's complement of what? 9. Okay, that means this is the negative number. So this is the negative number. How? Because the first bit is minus. So we will write the minus. Now we need to check. Now we need to check the first complement of x and second complement of minus 9. If both values are matches, see, when we use x and when we use negation operator, we get minus 9. We get minus 9. And this one is minus 9 binary representation, because minus 9 is a negative number and that number will be stored in a memory with our form of 2's complement. So when we use x, we get this value. Okay, we get the value. Just we need to match 2's complement value with 1's complement value of positive number. We'll check positive number 1's complement value with negative number 2's complement. If the both values are matches, then we can say that when we press x, we get minus 9. Okay, when we enter negation of add, because we get the minus 9. Did you get that? Did you get that concept?
Yes, sir. Yes, sir.
What about other students? Just try for another numbers. Okay, just क्या करो कि आप दो तीन नंबर के साथ try करो, you will get the brief idea regarding that. Okay, or this is the valid reason. Okay, when we see a number of videos on YouTube how to calculate the negation operator in binary, you get lots of confusion. Okay, उसका proper answer कोई भी नहीं, कुछ भी कोई भी करता है, like they will apply 2's complement on integer. Okay, so when we apply the 2's complement inside that integer, how I will get that value? Because here I have made one statement. That statement is the negative number is also stored in a Python with the help of 2's complement. That means when we perform 2's complement on negative number, then we can able to store na. So when we trying to apply the 2's complement on 8, is it feasible to get the value? The answer is no. The answer is no. And according to the this logic, जैसे हम जावा में करते हैं, मैंने पता है ये लॉजिक भी आप इस पे अप्लाई करते हो ना, so in that section also we get the minus 9, because the first bit is minus 128, but here in Python there is a no concept of range, so that's why here we cannot able to apply this logic. Okay, so hopefully you will get the idea. So what should I do? I will do one more time, and here I will use a different kind of value, so you will get the brief idea. So it's quite confusing. Here I'm using a 35. Okay, and we all know that when we perform the negation of 35, here I'm directly perform the negation of 35, we get the minus 36. अब ये मुझे बताओ कि what is the 35? 35 is a positive number, and what is the 36? 36 is a negative number. So can I say that 36 is able to store in a Python because we apply the 2's complement. अब हमें apply करने की जरूरत नहीं, the internal operation is going on. Okay, so minus 36 directly नहीं store होगा, वो store होगा but in the form of 2's complement होगा. That means when we press minus 35, we get the minus 36. Okay, so here we do what? Just 1 minute. So here we'll calculate the binary for that. So here I'm not using 128, not using 64, I'm using 32-bit, I'm not using 60, not using 8, I'm not using 4, using 2, and I'm using. So can I say that this one is binary of 35? Yes. So let's do and let's perform. Okay, so let's assume that we need to calculate the minus 36. Minus 36. I want to calculate minus 36. According to that, we will calculate the 35. मतलब cross करके देखते हैं तो आंसर आता है क्या? So 36 is nothing but here we need to use 1 and rest of all bits are 0. 32 plus 4, 36. Let's do 1's complement. अभी reverse operation perform कर रहे हैं. 1's complement is nothing but 1 1 0 1 1 0 1. So we all know that the negative number will be stored in the Python with the help of 2's complement. So here we need to perform 2's complement. Here we need to perform 2's complement. I will perform the 2's complement. Just we need to add one value inside that. Just we need to add one value. So 1 plus 1 we get the 0 and carry will be generated over here. So यहाँ एक carry generate हो जाएगा. So again here one carry और ये previous value 1 plus 1 again we generate one carry. ये carry यहाँ आ जाएगा. Okay. So 0 plus 1 we get the 1. So carry का concept खत्म हो गया. So यहाँ इसके नीचे 0 ही रहेगा. So 1 plus 0 we get the 1. Maybe problem here. This is the binary of 36. Is it 36? 32 plus 4? Yeah. Yeah, we are doing just 1 minute. Plus 1 we get 1 plus 1 we get the 0. Carry will be generated. 1 plus 1 we get the 0. Carry will be generated. 0 plus 1 we get 1 back. Yeah. So here we get the 1. This. Just 1 minute, okay. So we'll do in a straight way. Don't be confused. Later on, I'm using because 30 plus 2 plus 2. Now we do the ones complement. Now we need to calculate the 36. Yeah, we got the problem because we did the wrong way. So here we need to calculate the minus 36. So as we forget about the minus symbol, about the minus symbol. So here I'm using 0, 0, 1, 0, and here I'm using 0, 1, 0. So this one is a binary of 36. So what is complement? 1 is complement. So it will be replaced by 1, will be replaced by 0. We get the this value. Now we need to apply the 2's complement. So मैंने प्रॉब्लम क्या किया था पिछली बार 35 को 2's complement ऐड करने की कोशिश कर रहे हो. So for that I got the wrong value 35 को. So we cannot able to apply the 2's complement on integer number because the number negative number will be stored in the memory. Negative number will be stored in the memory, and for that we need to apply the second complement. So don't worry about that. Here we'll add only just plus. Now we get the result. 1 plus 1, we get 0. Carry will be generated. Again 1 plus 1, 0. 1 plus 0, we get 1. That's it is. We get the value as 1. Here we get the 1. Here. So now just check this value with this. So what? So does it match?
No, sir.
Okay, just let's make in we need to get 100 100 0 100 values are quite 16 plus 32 32 plus 2 34 get this value negation is perfect. 0 replaced by 1, 0 replaced by 1, replaced by 1, 0 replaced by 1. Okay, so here 36. So all rest of bits will be replaced by 0. So 1 plus 1. Value 0 value carry will be generated. Here we also get 1 plus 1 0 carry will be generated. So here get 1 plus 1. Here plus 1 1 यहाँ तक तो ठीक है यहाँ भी ठीक rest of bit. Okay, here we get the confusing step. थोड़ा सा कंफ्यूजन यहाँ ऐसे हुआ है कि मैं पर वैल्यू यूज किया हमने. So let's do one more time. So थोड़ा सा confusing. Just do the practice. So 1 plus 1 0 carry will be generated. 1 plus 1 again 0 carry will be generated over here. So ये थर्ड नंबर का बिट चालू है यहाँ as it is 1 आ जाएगा. अभी फोर्थ नंबर का बिट क्या है 1 है. फोर्थ नंबर का हम as it is 1 ही यूज करेंगे. फिफ्थ नंबर का बिट क्या है फोर्थ नंबर का 1 है. फिफ्थ नंबर का 1 है. सो फिफ्थ नंबर का भी एज इट इज 1 यूज करेंगे. सिक्स्थ नंबर का क्या है 0 है. सेवन नंबर का क्या है 1 है. ओके सो एट नंबर के क्या है 1 है. सो नाउ जस्ट वी चेक क्रॉस वेरीफाई द वैल्यूज. Just we cross verify the values. Did we get the same values? Did we get the same values? 1101 1101. Okay, double one double zero double one double zero. Is it okay? Now, did we get the same values? So just make a note on that.
Yes, sir.
I will suggest one only thing. While performing the operation on negative, when we performing the operation of negative, use 2's complement on negative number. Do not try to use 2's complement on positive. Okay. Just we will match. When we use X, we get minus 36. That's why here I did a one's complement. And when I perform the two's complement, we all know that what is two complement. First of all, we need to do the one's complement and we need to add one element and we get the two's complement. That number will be stored in a memory. That number will be stored in a memory and it will represent the positive negative number. It will represent the negative number because the memory does not support to store the negative number. And if you want to store, then we need to use the concept of what? We need to use the concept of. Okay, so hope so you will get the idea regarding it. Is it clear? All students. So let's do what? So just you need to cross verify like that and I will give homework for that. So just you need to try x is equals to 77, x is equals to 90, x is equals to 70. So just do the practical for that. ये इसका practical आप perform करो and just first of all just use x, convert it into the binary, later on calculate the ones complement, and after that we get the minus 878. Then calculate the binary of minus 78. Okay, later on convert it into one's complement and after that use two's complements and just match the output of first value with another value. If we get the same, then definitely we can say that what the given number is valid. Okay, so we can able to convert and this is the proper answer. Okay, the answer na aapko you can check on the what we say, you can check on the Python help section or Python documentation. ये इसके अंदर भी बताया, but rest of do not watch the videos of this bitwise operator because it's quite confusing और आपका confusion level और भी बढ़ेगा और कुछ भी बोलते हैं लोग ज़्यादा. Okay, so like मैं I will show you one example how they did. They will calculate the binary of this. Get the value of this binary. So they apply the negation on that. That they apply the ones complement for that. Okay. So how will get the value? So just 1 plus 1 0 we get the carry 1. Okay. All bits are same. can you say that this value is minus 3? No, we cannot say. ये वैल्यू माइनस 3 होगी क्या? इसके हिसाब से हम कैलकुलेट ही नहीं कर पाते. Okay, so don't worry about that. Forget about that. All things. Worry about that. Just understand this concept. Okay. Now let's quickly revise for the left shift and right shift. Now here I'm using a left shift. So what is that? So just left shift operator. Okay, we can shift 1 bit, 2 bit, 3 bit, 4 bit, whatever you want. Okay, and this one is a right shift. Okay, so that will be applied on only bitwise operators. This one is a left shift. I will explain very briefly left shift, and you will get the idea. Just we can use, assume that we have a variable a and whose value is a 10. So first of all, we need to convert this into the what binary. So here I'm trying 1 0 binary of 10. When we're trying to use a left shift, that means a is a variable will be shifted by left shift by 2. We can use 1 bit, we can use 2 bit, you can use 3 bit, you can use 4 bit, whatever bit. But generally, most of things they are using, we are using a 2 bit. Okay, we need to shift 2 bits. What does it mean? Here I have value a that contains 10, and I'm trying to shift 2 bits left side to the. I'm trying to shift 2 bits to the left side. Okay. लेफ्ट साइड को मैं 2 बिट शिफ्ट करना चाहता हूँ तो इन दैट केस जस्ट ये एज इट इज ही रखना है इसको कुछ भी चेंज करना है जस्ट add two empty compartment to the right side just add left shift है तो right side just add to empty compartment means empty values add करना है दो zero values empty add करना है so here I'll add 0 and here will add होगा आंसर आ गया आपका सो हियर वी नीड टू कैलकुलेट द बाइनरी अब यहाँ हमें कैलकुलेट करना है सो हियर इज 32 अब ये आना चाहिए आपको दिस वन इज 16 दिस वन इज 8 आफ्टर दैट 4 आफ्टर दैट 2 आफ्टर दैट ओके सो नाउ जस्ट कैलकुलेट द वैल्यू जितने वंस है उनके एडिशन करो सो हियर 32 is there 8 is there 32 plus 8 40 so we get the 40 answer so when we perform left shift to the A. So A means 10, then we get the 40 value. So let's check out A left shift to the what is A? A is equals to 10. A left shift. बहुत easy way से बता रहा हूँ. Let's do another example. X is equals to 20. What is the binary of 20? 0 0 0 0. So this one is a binary of 20. We all know that. Just we need to shift 2 bits. Okay. So हमें 2 bits additionally add करने हैं. So this one is binary. What should we do? We'll add 2 empty bits to the right side. Left shift मतलब right side को 2 bit add करना है. 1 2. Now we need to calculate. अभी ये total 10 bits है. इसमें से पहले 2 bit निकाल दो. क्यों निकालना है सो नहीं निकालना है तो लेट्स डू वन थिंग सो एप्रोप्रिएट बाइनरी 20 का ढूंढो क्या है 1 1 दिस इज द एप्रोप्रिएट बाइनरी this one is an appropriate binary ये binary होगा ये this one is a 16 bit so first one is 1 2 after that 4 after that 8 after that 16 so 16 plus 4 20 so नहीं याद आ रहा है so just यहाँ जाओ and binary of 20 calculate करो so we get the value 0 भी remove कर दो 0 भी को 10100 आना चाहिए so what will be the binary 10100 appropriate so just इसको क्या करो 2 bit add कर दो ऐड करने हैं लेफ्ट साइड को ऐड करने हैं सॉरी राइट साइड को मेरे राइट साइड को ओके So right side को left side मतलब right side को add करना है. Now you can calculate. Okay. So what is this 0? So this 0 is nothing but 1. What will be this 0? 2. What will be this 0? 4. What will be this 0? 8. What will be this 1? 16. What will be the 0? 32. And what will be the last one? 64. अच्छे से arrange करते हैं. Check out 64 plus 16. Okay, so we get the 70, 80, 80 value. So when we perform X 20, okay, and when we shift 2 bits, that means here X left shift by 2. Okay, 1 kiya to just we need to add 1 bit to the right side. 3 kiya to we need to add 3 bits to the right side. Okay, so just perform X is equals to 20 and X left shift to the 2 bits. So we get the 80 value. So let's do one more example. So here I'm trying to use X is equals to 40. This way we can use a simple value 30. So easily we can. What will be the appropriate binary? So 1 0. This is the appropriate binary because 1 2 4 8 16 and 32. So here we need to do what? Here I will shift X shift by 1. Just I want to shift 1 bit. So in that case, what should I do? I will add only 1 bit to the right side. So here, because I want to shift 1 bit. Now we calculate what was that? This 0 is 4, this 0 is 2 and this 0 is 0. So 0 की वैल्यू 0 ही होती है तो उनको एडिशन में नहीं लेते हम अगर 1 होता है तो ही. So we get the 64. आउटपुट क्या आएगा 64. Let's try for that. So x is equals to 32. X is equals to 32. Shift 1 bit. Shift only 1 bit. So we get the output. Okay, so hope so you will get the idea regarding that left shift operator. Similarly, we will do for the right shift. So here I'm do what x is equals to that tag. To use 10 bit कहाँ shift करना है x right shift x right shift to the 2 bits. So in that section make a note of that section जब भी आपको लेफ्ट शिफ्ट यूज करना है राइट शिफ्ट यूज करना है लेफ्ट शिफ्ट यूज करना है देन राइट साइड को मूव कर राइट साइड को 2 एडिशनल बिट्स देने हैं एंड अगर आपको राइट शिफ्ट करना है तो लेफ्ट साइड को 2 बिट्स ऐड करें 2 बिट्स ऐड अगर हम लेफ्ट शिफ्ट यूज करते हैं लेस देन यूज करते हैं तो हम यहाँ 2 बिट ऐड करेंगे अगर हम राइट शिफ्ट यूज करते तो हम यहाँ 2 बिट ऐड करेंगे. Here what should I do? I will use 0 0 bit मैंने ऐड जस्ट ऐड करके कुछ भी नहीं है. So when we use the what do we say right shift operator, just do what just do just remove the first two elements. That section आपको क्या करना पड़ेगा दो elements आपको directly remove करेंगे करना पड़ेगा left side से. Okay, so यहाँ right side से हम जब दो element add कर रहे थे तो right side के लिए यहाँ आपको दो elements remove करना पड़ेगा directly. That means we get only 1 and 0. Here we remove these 2 bits. Okay, that means we get only 10. 10 means what? We get only 2 value. So binary of 10 is nothing but 2. Just we need to remove these 2 bits. ये 2 bit left side here. Let's check about that. X is equals to 10. X is equals to 10. I'm using you X. And I'm using to right shift operator. We get it. Let's take one another example. Let's see. X is equals to 15. Values as so we need to remove these 2 bits. ये 2 bits remove करने हैं. So instead of that, just we need to add 0 0 and last के 2 bits as it is written. So we get 3. Okay, so this is nothing but 3. Let's check about that. X is equals to 15. X is equals to 15. X. हम ज़्यादा यूज नहीं करते but मैं convert of that. See, we get 30. Okay, so this is about what? Left shift and right shift. Just watch this video if you have any query regarding that. Okay. So did you get that concept?
Yes, sir.
Okay, so just I will close the lecture and I will start the new DBMS lecture at 9 o'clock. Okay.